Okay, so I want to finish up some problems from lesson 511 and 512. We combined it for class. We did most of these problems, but just make sure that you were back in this document, 511 and 512. So I'm going to go ahead and scroll on down. We practiced a lot of rearranging these types of problems in order to rewrite them in the y equals mx plus b form. So I think I'm going to go ahead and do E and F because those look a little bit more difficult than a few of the other problems. So we want to make sure again that we are in the y equals mx plus b form because the m tells us our slope. Or in this right here I wrote growth, but this is the slope. Same thing. Okay, and then the b tells us the y-intercept, or some of you may still call it the starting point. So what I want to do over here in this equation here, I'm going to rearrange the terms to where it is where y is by itself. So basically we are solving for y. So we're getting y all by itself to figure out what y equals, and then we're going to make sure it's written in the mx plus b form. Okay, so the first thing I need to do here is distribute this -3. So this is attached to our parentheses, so we're going to go ahead and distribute it. And remember, please pause throughout the video so that you're not rushed. Try to do the problems on your own, but I am going to go through rather quickly just to make this video a little bit shorter, so make sure that you are pausing if you need more time. So here I'm left with 5. -3 times x is -3x. -3 times +1 is -3. And this equals 2y minus 3x plus 2. So now I notice, okay, my y over here is on my right-hand side, so I'm just going to leave that there. I don't want to move it, but I need to move everything else away from that y. Okay, so first things first, you can also combine some like terms here. 5 and -3. 5 minus 3 is 2. And then I still have my minus 3x equals 2y minus 3x plus 2. So you guys might notice something that this is the exact same as this. So we're going to see what happens once we start to solve this problem. So now I'm going to go ahead and let's add 3x to both sides to move it away from this 2y right here. So now I'm still have the 2 here. These cancel out, and this equals 2y. These also cancel out, plus 2. Okay, I'm going to go ahead and move this 2 over here. So we have 2 equals 2y plus 2. My 2y is still on the right-hand side, and we need to move this 2 away from it. So now we end up with 0 equals 2y plus 0. So we don't need to write that. The y is still not by itself, so now we have to divide both sides by 2. So we get y equals 0, and that is perfectly fine, okay? So y equals 0, if I were to graph that, that is still a line, okay? So if I were to graph this, let's make this a little bit bigger. We're going to have y equals 0. It is a straight line. It is flat. And that is why there is no slope. You notice there's no number times x. There's no m, okay? So because there's no slant to this line, if there was a slope, it would be slanted either up or down. So here, our final equation is y equals 0, okay? And so we know that our growth, or the slope, is 0 because it's 0x, right? There's no x. And our y-intercept is 0. That's where it crosses the y-axis there. Okay? So that one's all done. So same idea here. Again, we want to rewrite this in the y equals mx plus b form. Okay? So let's go ahead and do this one. And please make sure that you are pausing throughout the video so that it's not going too fast for you and whatnot. Go at your own pace. Okay, so here the first thing I need to do is distribute this negative. So this negative is what is attached to the parentheses, not that x, okay? That x is being added there. So here I'm left with x, and then negative times y is going to be a negative y. Negative times positive 2 is a negative 2. And this equals, it looks like I have to distribute on this side as well. This 2 needs to be distributed into these parentheses. 2 times 2x is 4x. 2 times 1 is positive 2. Okay, so now I notice that my y is here on my left-hand side, so I'm going to leave it there. So I'm going to subtract x here from both sides. So over here I'm left with, again, my negative y minus 2. Just brought each of those down. 4x minus x is 3x, and then just bring down this plus 2. So now I have negative y minus 2 equals 3x plus 2. Again, I want to leave that negative y over here by itself, so I need to move away this negative 2 by adding it. You do the opposite operation on both sides to get rid of it from the left-hand side. So I still have negative y here. I still have this 3x. So this is 2 plus 2 is 4. So now I'm almost done, but the y needs to be completely by itself and it needs to be positive. So I need a positive 1y. Right now it's a negative. So I need to divide both sides by a negative 1. And whenever you divide this entire side by negative 1, that just means you're dividing each term here by negative 1. Anytime it's separated by a positive or a minus sign and it's not being multiplied or anything, you have to do it to each term. So here, we're going to end up with a positive 1y. 3x divided by negative 1 is negative 3x, and positive 4 divided by negative 1 is negative 4. So this will be my y equals mx plus b form. And I know in y equals mx plus b that the m is in front of the x, so negative 3 is my slope. And the y-intercept is the constant with no variable, so my negative 4 is my y-intercept. So over here on the right in your box, you want to make sure you write that. Growth is slope. In this case, it was a negative 3. And the y-intercept here is a negative 4. Okay? So now down here it says, solve the problems below for the indicated variable. So part A says solve for x. All right, so let's go and give this a shot. So y equals negative 3x plus 6. So I'm going to go ahead and draw my line down the equal sign. And basically, I need to move everything away from this x because I want the x to be by itself because this says solve for x. Okay, so my first step I'm going to do is I'm going to subtract this 6 away from this side because that's where the x is. So now I have y minus 6 equals this negative 3x. And 6 minus 6 is 0. So now I'm like, okay, I'm almost done, almost there. But my x here still has this negative 3 attached to it. I need the x to be by itself. So now I'm going to go ahead and divide both sides by negative 3. And again, whenever you end up dividing something like this by a negative 3, you can split up the terms at the top. So this is going to be y divided by negative 3 minus 6 divided by negative 3. These two will cancel out, so this equals x. But now we got to simplify it, right? So we have negative y over 3. This is like negative 1/3 y. Negative 6 divided by negative 3 is a positive 2. So now I know that x equals negative y over 3 plus 2. And again, it does not matter if the x is on the left or the right side. I could have also written x equals, you could also write negative 1/3 y instead of y over 3. It's the exact same thing, plus 2. So any of these would be correct. Any of those would be correct. The reason why we can write the negative 1/3 y is because it's the coefficient of y. It's the number that's in front of it. It's not just a negative 3 and then the y is thrown up top. No, this is negative 1/3 times y would be times y over 1. So negative 1 times y is negative y. 3 times 1 is 3. So that's why you can write it as either negative 1/3 y or as negative y over 3. They're the exact same thing. Okay? So any of those is fine. All right, so now this one also says solve for x. Okay, zoom in there. So I'm going to find all my x's. So it looks like I have 2 on each side, or 1 on each side of the equation sign, 2 total. Okay, so here the first thing I need to do is simplify each side. Over here I can distribute this 3. Okay, 3 times 2x is 6x. 3 times positive 4 is a positive 12. And then here I see that I can combine like terms. 2 plus 10 is 12. And then I have this 6x. Ooh, interesting. You guys notice something here? They're the exact same on each side. So you might remember what this is, but let's go ahead and just move all the terms around. So I can subtract 6x from both sides. Those two cancel out, so I end up with 12 equals 12. And that is definitely true. Okay, so this means whenever you have sides that are equally true, right? They are completely equal, equally true. It's like a redundant statement, but they are both equal. If you subtract 12, you're going to get 0 equals 0. So x is all real numbers. You can plug in any number for x. If you plug in a 1 here on each of the x's, you're going to get the sides are equivalent. If you plug in a 2, you're going to get that the sides are equivalent, right? If you plug in a 0 and multiply those by 0, you're going to get equivalent sides. So no matter what you plug in, you're going to get two sides that are equal to each other. So whenever you have something where they're the exact same on each side, you have x equals all real numbers. You can plug in any number for x. That one's a special case. Okay, so now here's for part C. It says solve for p. Okay, so for p, I see that it's only on the right side. So we just have to start simplifying first and then start moving all the other terms away from the p, variable p. Okay, so my first step here is looking at the left-hand side, all I have is an m. So I'm just going to leave it as an m. Here I have this 8. But I notice next to the 8, I can distribute that -2. So this -2 gets distributed in. Make sure you don't forget that negative, okay? That's really important. -2 times p is -2p. -2 times -m is a positive 2m. Okay? Now I notice that the p is on this side, so I'm just going to leave it there, and I'm going to move everything else away from it. The first thing I'm going to move is this 2m because I notice it can be combined with this m over here. So I'm subtracting 2m from both sides because it is a positive 2m over here, so I have to do the opposite to cancel it out. m minus 2m, this is basically 1m minus 2m. 1 minus 2 is -1m. Still bring down this 8, and then all I have left is 8 minus 2p because my 2m's canceled out over there. So now I still have p on the right-hand side, and there's still other terms attached to it. So I'm going to go ahead and subtract this 8 from both sides. So it cancels out on the right. But right here, I cannot combine it with the m because they both don't have a variable. Okay, so m is only attached to the -1. The -8 is a constant. So we're just going to write -1m minus 8 equals -2p. And now we're so much closer to getting the p by itself. Okay. All right, so now what we can do is divide both sides by the -2. All right, -1 over -2. That would be 1/2, or you can even write 0.5. Either one is fine. I think some of you like to put it as a decimal, and that's fine. This is a nice decimal because 1/2 is exactly equal, like perfectly equal to 0.5. Whereas like something like 1/3 would be 0.3333, repeating forever. So it's a repeating decimal. But this one is an exact terminating decimal, which means it ends. So it's a pretty decimal. That's what I like to call it. It's pretty. And then -8 over -2 is a positive 4. These two -2's cancel out to 1 because negative 2 divided by negative 2 is a positive 1. So all we're left with is 1p. And that's what we did. We solved for p. So this is your answer, okay? Again, it doesn't matter if the variable you're solving for is on the left or the right side, but you could rewrite this as p equals 0.5m plus 4. Or if you had left this as a fraction, this is also correct. It's the exact same thing. And just like earlier, whenever you have a fraction in front of a variable, that variable could go up top with the numerator. This could be 1m over 2 plus 4, which what we did in the previous problem is we just wrote this as the variable over the denominator, because if it's 1m, that's just m over 2 plus 4. So literally any of these is the correct answer. These are all equivalent equations here. They're the exact same. So you're good to go with whichever one of those you pick, okay? All right, so now let's go ahead and solve for q here. So if I draw a line down my equal sign, okay? Let's see here. All right, let's go ahead and distribute the 4. Sorry, I was reading an email at the same time, multitasking here. 4 times q is 4q. 4 times negative 8 is negative 32. Okay, equals 7q plus 5. I always put a little, like my q's, I don't go like that because it kind of looks like a 9. So I always put a little edge to it back there. Some students do the loop still like that. Whatever, just make sure it doesn't look like a 9. So I see here that I have my variable I'm solving for on both sides of my equation. So I need to move it over to one side. It does not matter what side you move it over as long as you continue doing all of the legal moves you need. So I'm just going to go ahead and move it over to the right-hand side. So I'm going to subtract 7q from both sides. Whoops, that's not what I wanted to do. There we go. Okay, so 4q minus 7q is negative 3q. Bring down the negative 32. Those two subtract out to 0. And all that's left on the right-hand side is a positive 5. So now I see, okay, my q's on my left-hand side, I have negative 3q minus 32 equals 5. So I am going to add this 32 to both sides to get, oops, to get rid of that 3q there, or to get the 3q by itself. I'm sorry, I'm not talking right today. So here I have negative 3q equals 37. 37 is actually a prime number, so it's not actually divisible by negative 3. I'll show you what that looks like. So we have to divide both sides by negative 3. So I'm left with q equals, and let's see what we get if we try to divide 37 by 3. Usually anything divided by 3, it's a repeating decimal. So you should know that it's not going to be pretty. See, this one's 12.3 repeating. So honestly, we can just leave it as a fraction. Okay, so this equals negative 37 thirds. You can even write it's about equal to 12. 12.3 repeating. Negative 12.3 repeating. It is a negative. But honestly, like, this is the best exact answer there, is the negative 37 over 3. Okay, that's exactly the answer. All right, so we did talk about this briefly in class, and I'll just quickly go through. We came to the conclusion that in order to make this have no decimals, we needed to move this over twice. Okay, because this one we can move it over twice and it still works. There's no decimals, it's a whole number. But we can't just move them over and not understand what we're doing to move them over, right? So I talked with my students, and I had one student, she said, make it a percentage. And I think she remembered how I told you guys that if we had like a probability and it's 0.03 chance of it happening, to make this a percentage, you do times 100. Okay, because all percents are out of 100%. A whole is 100%. So we're going to multiply this by 100. 0. I don't know if you guys remember these multiplication rules or not, but this is how I learned it. And then that decimal here means I'm going to move this decimal back 3 times. Or I'm sorry, 2 times to the 3. So this is going to be 3%. But I could show you a little bit easier in a calculator, right? So here we have 0.03 times 100. I get a positive 3, just 3, whole number 3, okay? So here, if we multiply this whole thing by 100, because if you're manipulating equations, you have to do every single piece of it, right? So if we were to do 100 times 0.04, I get 4, okay? So this is going to be 4 plus 100 times 1 is just 100. Oops, sorry, 4x. And then 100 times 2.2 is 220. Now the reason for this is because we need to solve for x here, and some students get a little bit confused whenever there are decimals. I mean, you can solve this being a decimal just fine and you'll still get the right answer. However, some students like the look of this one a little bit better, and they believe they can handle it easier than the one with the decimals. So here, if we subtract 100 from both sides, okay, we're going to have 4x equals 120. So I'm going to divide both sides by 4 to get that x by itself. We get x equals 30. I'm going to show you that we would still get the same x value even if we left it written as decimals. 0.04x plus 1 equals 2.2. All right, so let's see what this looks like. So here, I'm going to subtract 1 from both sides. It's like 1.0, basically. It's just 1. So I'm left with 0.04x equals 1.2. And now I'm going to divide both sides by 0.04. Remember, you can always use a calculator, right? So if I open up my calculator, I'm going to have 1.2 divided by 0. Oops, I did it backwards. 0.04. Wait a minute. Oh, yes. Wait. Yes, 30. I thought I got 3 for some reason. Oh my goodness, I'm tired, guys. Yes, so we get 30, right? We still get 30. X equals 30. This means 0.04 goes into 1.2 30 times, just like 4 goes into 120 30 times. So we get, look at me, I just did 3 again. I should not be making a video this tired. So we do get 30 for both of them. So no matter what, you get the same answer. But again, some students like to rewrite equations to make them a bit easier to handle and look at. Okay, so now that we know that we can rewrite equations and whatnot, let's just look at this one. I looked at it in class with you, but let's review it real quick. So here we are given this original equation, and this one would be pretty nice to solve. But I want to see what we do to get each of these equations down here. So I'm going to go ahead and color code them. We're going to talk about what is different from the original to each of these individual equations here. They are all equivalent. I will tell you that. These are all equivalent equations. Okay, they all stem from one of them, and then you do the same thing to all the sides. So to get from the original to the orange one, it looks like we multiply everything by 10. So I'm going to write up here, multiplied by 10. We multiplied this whole equation here by 10 to get 20x plus 10 equals 30. And if you were to solve for that equation, you would get the same x value as you would the original. So now to go from the original to the blue one, students, I had some students say multiply by 100 because they saw the 2 zeros here. So I was like, okay, well, let's try that. If we were to multiply the original by 100 times my original, distribute that. So we have 200x plus 100 equals 300. That is not the same. So it looks like whenever we multiply by something like 100 or 10 or 1,000, the numbers get bigger. But in this case here, Our numbers are smaller because they are decimals. So in order to go to a smaller number, we either need to multiply by a decimal or divide by a big number. So then I had some students say, oh, let's divide by 100. Okay, so if we were to divide 2x plus 1 equals 3 by 100, every part by 100, you're going to get 0.02 hundredths x plus 0.01 equals 0.03. And they noticed, okay, well, that's not enough zeros, so let's divide by 1,000. Okay, so if we had the original equation and we divided each piece by 1,000, we used a calculator to look at that. So if we have 2 divided by 1,000, we get 0.002. 1 divided by 1,000, we get 0.001. 3 divided by 1,000, we get 0.003. And what you would call these place values is 2 thousandths with the THS at the end, 2 thousandths, okay? That is what this one is. This is 2 thousandths x plus 1 thousandths equals 3 thousandths, okay? So this one, we divided by 1,000. You could have also multiplied by 0.001 and you would have gotten the same answer there. All right, so now to go from the original to this one. This one tripped students up because they only did something to the left-hand side, but what they did was not necessary to be done to the entire equation. All they did here was they factored out a 2, which means they divided each of these terms here by 2. 2x divided by 2 is 1x, or just x. 1 divided by 2 is a half, or 0.5. And then they accounted for dividing that 2 by putting the 2 out in front. Because if you were to multiply this back in, you're going to get 2x plus 1 equals 3. And that's the original equation. It's the same thing. Okay? Let me get rid of all my little notes here. So what we did to go from the original to the green one was we factored out 2 on left side. Factored out a 2 on the left side. Now this red one tripped up a few students. This was a good one though. So my original is 2x plus 1 equals 3. So students were like, well, I think it's divided by 3, but I don't know how we got this 1 here on the right. Well, okay, let's look at that. If we divide everything by 3, yep, that's 2/3 x. Yep, that's 1/3. What is 3 divided by 3? 1. So this one we divided by 3. Everything by 3. And then you get 2/3 x plus 1/3 equals 1. So this example was just for you to see what is happening, right? What is changing here? And that they are all equivalent. You can just undo what you did by either dividing by 10, multiplying by 1,000, multiplying by the 2, or multiplying by that 3. And you're going to get the original equation 2x plus 1 equals 3. Okay? So let's go ahead and look at this. We're going to create equivalent equations to make these a little bit easier to handle. So I notice here I have some decimals. Now these decimals are all in the tenths place. Let's look at place value real quick. So I'm just going to make a random number here. Let's take some notes. Write this down on a piece of paper. I'm just going to go 123.456. Okay? So let's take some notes here. This is, oh, you know what? Let me go back. I'm going to add a 7 here. So this is what we call the thousands. This is 7,123.456. This one would be the hundreds place. The 1. The 2 is the tens place. 2 tenths is 20. This is the ones place. Okay? This one right here, 0.4, is the tenths place. Tenths place. This 5 is in the hundredths place. And it's because 0.45 equals 45 out of 100. Okay? Just like 0.4 is the same as 40 out of 100, or it's 4 out of 10. So that's why it's the tenths place. Okay? And then the 6 here is the thousandth place, because it's the same as 0.456 is 456 out of 1,000. It's 456 thousandths. That's how you would say 0.456. Okay, thousandths. All right, so these are very important for you guys to remember, because place value is so important for you to understand how to really manipulate equations to make them easier for you to use. Okay, so let's see what we can do here. I'm going to go ahead and erase this, right? So here I notice we are in the tenths place. So to undo something that's in the tenths place, or to rewrite those as whole numbers, I need to multiply everything by 10. Because then that will move my decimal over 1 time here. Okay? So if I multiply everything by 10, feel free to use a calculator if you don't believe me, all right? Or if you don't see how I'm getting these numbers. 10 times 2.1x will be 21x. 10 times 0.6 will be 6. 10 times 17.4 is 174. So now this is just a little bit more manageable for you. To solve this, let's go ahead and subtract 6 from both sides. Those two cancel out, so we get 21x equals 168. So we're still solving for x here, so divide both sides by 21. We're going to get x equals 88. Oh, no, not 88, gosh, 8. 21 times 8 is 168. X equals 8. Okay? So that one's a little bit easier than doing it with the decimals. Let's look at B. These are pretty big numbers. I think you can definitely solve these on your own, just as is, but let's make them look a little bit smaller. So what we can do here is we can either multiply by 1/10 or divide by 10. So dividing something by 10 is the same as multiplying by 0.1 or 1/10. It's the exact same thing. Okay, division and multiplication has a lot of connections between the two. But here, let's just go and divide everything by 10. And it's legal because we're doing it to everything. These cancel out one of the zeros. So now we have 10x plus 25 equals negative 40. So now we can draw a line and go ahead and solve for this problem. Subtract 25 on both sides. We're going to have 10x equals negative 65. Divide both sides by 10. So we're going to have x equals negative 6.5. And you would have gotten that same answer if you had just done it with the hundreds. That's totally fine. Okay. All right, let's go and see what's next. Oh, did I miss? Oh, there it is. Okay, so here I have a division of something by 3. I don't like having a fraction like that. So what I'm going to do is I'm going to multiply this whole equation by 3. Okay, because whenever I multiply by that, the 3's will cancel out, and I'll show you how that works. So this is going to look like 3 times the 2x over 3 equals the 3 times 30. So what happens here is you can either rewrite that as 6x over 3, which is 2x, or you realize 3 divided by 3 is 1, so we're left with 2x. So no matter what, you're left with 2x, okay? 3 times 30 is 90. Remember to be pausing because I'm moving pretty quickly. Divide both sides by 2. We're going to get x equals 45. And that is a lot easier. So seeing something that's 2x equals 90 is way easier than seeing something that says 2/3 x equals 30 and solving for x there. Okay? All right, so again, this one, I see that I have a 5 in the denominator, and I don't like working with fractions like that. So in order to solve this one, what I'm going to do is multiply the entire equation by 5. So this is going to be 5 times x over 5. And then it'll be plus 5 times 1 equals 5 times -6. And just so you guys don't think it's 5 minus 6, I'll put it in parentheses. Like that, see? You can put all of them in parentheses. So 5x over 5 is just 1x. These 5 over 5 is just equal to 1. So we have x, 5 times 1 is 5, right here, equals 5 times -6 is -30. So now this one is way nicer looking than the other one. Now we could have subtracted 1 from both sides up here. You would have gotten x over 5 equals -7, and then you could have multiplied both sides by 5, and you would get the exact same answer. But again, you can multiply the entire equation by some number to make the whole equation a lot easier to work with. So now here, my last step, sorry, I forgot to draw my line, is to subtract 5 on both sides. Again, always check your work with the calculator. Some of you still get tripped up on some of the negatives, so make sure you're double checking your work. -30 minus 5 is not -25. It's not +35 or +25. It is -35. Okay? All right. Let's see what's next. Okay, so now here, I think I kind of want to do this one in class. So I'll do this one in class in our next class together. But this up here really helps you understand what we're going to do in class, okay? It's just going to get a little bit more difficult. So hopefully this video helped you out.